Thank you everyone for joining us today. As you see, our Revizto experts will present the webinar titled Reality Capture with Revizto, exploring powerful use cases with cutting-edge scanning technologies. All right, so we'll go. Now I'm going to talk about the agenda. So we're going to talk a little bit about the housekeeping items. You're going to meet Juan Diego and Matt Ivers. They're going to talk about the types of reality captures and use cases, georeferencing and coordinate systems, reality capture project examples, reality capture best practices, and the Q&A part. All right, so the webinar is being recorded and the link will be sent tomorrow in an email as a follow-up for you guys and for everyone who registered. As you did right now, you can use the chat to engage with us or with other attendees. If you have any questions along this webinar, please add it to the Q&A box here on Zoom. We'll be answering them at the end. Also, please keep an eye out on the polls and participate live. And if you want to know more about Revizto and our future webinars and events, please follow us at Revizto on LinkedIn. All right, so now I'm gonna let Matt and Juan Diego introduce themselves. Go ahead.
Thank you, Stephanie. So I'm Matt Ivers. I'm the Western Region Implementation Service Manager at Revizto. I've been at Revizto for almost a year and a half now. It's gone by really fast, but I have about 18 years of experience, about 9 years in design. I'm a licensed architect, and then about 9 years in VDC as well. And I was most recently a VDC manager at Suffolk Construction for the last 6 years before I joined Revizto. I'll pass it off to
Awesome.
Juan.
Awesome, Matt. I'm Juan Diego Fernandez. I'm from Costa Rica and the Latin America ISM. So that's pretty cool to know that we as peers are working together in this type of initiatives. And yeah, I have like 8 years of experience. I'm not as experienced as Matt, but I have 5 years working in the field using this type of technologies and like I got the same challenges, like in how to where do I start? And that's what I'm really excited to bring like alongside Matt in this webinar. So yeah.
All right, so yeah, we'll have our first poll question. And Stephanie will go ahead and release that. So we want to kind of know, engage the audience, what is your most common pain point? I'm assuming we have a lot of people from various parts of the industry on the call. So we're going to have a lot of VDC, hopefully some reality capture enthusiasts, and even some design and engineers, hopefully. But we kind of want to know, what are the most common pain points that you're currently experiencing with reality capture? So I'm just kind of gauging right now where we're at. So go ahead and answer that. Perfect.
Nice.
Awesome. So yeah, it looks like it's quite a wide spectrum actually. We're seeing quite a few people with georeferencing and scan alignment, which honestly, that's my biggest pain point and challenge. And honestly, before I came to Revizto and got to meet Juan Diego, I really didn't know a whole lot about georeferencing and all the different coordinate systems. So I really learned a lot just by listening and practicing, and then, being around people in the reality capture space. So this is awesome. But we're definitely going to cover all these pain points. So don't worry, we're going to cover pretty much every topic that's a pain point on this poll question. All right, so we'll go ahead and dive right in. So why are we here? What are the main value drivers or main benefits for reality capture? As you know, it is it can be quite convoluted. There's a lot of technologies, there's a lot of different, people and roles in the industry. But one of the main drivers that I see is, how do you know what is true? It's almost like philosophical. How do we know what we're looking at is absolutely correct and true? And depending on your role, we may look at truth very differently in a different lens. But for building, it's highly litigious, it's highly risk. There's a lot of moving parts, a lot of players. But we obviously want to really rest assured that what we're installing is in fact per contract, and it is going to get installed in the correct location to hopefully, resolve those discrepancies or worries that we might have. And an architect, for example, they may look at something that they believe is, absolute, but it could be very relative to another person. A good example would be things like the grid lines. The architect says that's gospel. You go off of the grid lines. And so, a contractor will use that. But is that absolutely correct? How do you know that the grid line was placed correctly?
Yeah.
And it's the same thing with all the top of structures or shear walls. Those are permanent things, and a lot of people will use those, but they might be actually relative and it could be incorrect. So you don't necessarily want to use those as absolute gospel. Um, so this is kind of where we would see reality capture. It basically rest assures you that you know what you're installing is absolute and not relative because it's using the geoposition spatial coordinates, which basically all civil surveyors and engineers are going to use.
Yeah, I totally agree, Matt. Yeah.
So survey monuments, you're going to see us talking about that, and then we're definitely going to go into control points and how to properly geolocate those.
Yeah, I
From
can't
there,
wait to hear
obviously,
that.
these are derivatives from this. So you're going to kind of see us talking quite a bit about the geopositioning here. But yeah, to me, this is one of the biggest value drivers of reality capture is we're going to know what we're installing is absolute. So other main benefits, obviously with that objective data, we can now hopefully rest assured that there's going to be less litigation as a result. There's a very good paper trail of who's responsible for doing that. Obviously, it's the surveyors are licensed engineers, so they're going to obviously know that. But as we grow in an industry, it's going to be more helpful for everybody to kind of understand that concept to avoid less finger pointing. It is going to be probably the fastest and easiest way to capture the built environment. Obviously, with the advancements in technology and like lower price points, we're starting to see more people enter this space, which is really exciting. And that's going to lead to better quality and precisions to identify errors pre-construction. So
Yeah.
the beauty of VDC, obviously, we get to model things, but now we can capture the real world and bring it right into Revizto or a lot of other platforms and really see all that data, share it, democratize it to our audience that normally never gets exposed to this information. And as a result, we can now measure and quantify and verify what we're building is absolutely correct. Juan, did you have anything else on the benefits?
No, I feel like that pretty much covered it. One of the main issues that how can be sure that everything is placed where it needs to be. And like for example, if you need to correct some certain errors, like capturing like the volumetry or the verticality of a building or a structure definitely will help you to mitigate, how much rework you need to do. And that's something that we did a lot in the past because like construction error is pretty much common. So how can you deal with it? And reality capture really help us on mitigate those like interventions. Yeah,
Perfect.
and now we only have one disclaimer, and why don't we let like Malcolm Dad explain that one? Is that once you start, there's no going back, and that's true. The more you learn, the more you want to use it, and the more you want to standardize those process in your company. So that's pretty cool.
Yeah, this is so true. I mean, once you start to see the benefits, there's no going back. You're going to get more excited. You're going to want to learn more. And it's just incredible how much it's exploded, I guess, in the last 10 years. So
Yeah.
it's kind of like a Pandora's box.
Now, if we want to cover like where do I start, basically we need to define it. So basically, reality capture is the process to capture the physical world into an accurate 3D representation or model. So what Matt did here is a really good diagram on how it explains uh how because you have a lot of offers of reality capture, but you need to understand two main topics: accuracy and price points, and also like I would say the time consuming when setting up equipment. So that will be like a huge part of it. So as you can see in the pyramid, the lower you are on the base will be lower cost, but it will be lesser accuracy. Basically, what we are relying is more in photogrammetry. So basically, we'll reconstruct scenes, 3D scenes, but with less accuracy. So if you start like going way up, you'll start noticing like there will be more precise equipment. And what I really like about this is that you don't have to go for the best or the most accurate equipment for everything that you do. There are different types of jobs that you need to be done, and just to like sometimes you just need like a representation of what is like underneath or what is like hidden in like in a ceiling or something like that, because those were like the typical jobs that I used to do. I used to like place even my iPhone to scan like inside ceilings just to get an idea of what type of piping or systems are running over there. So that's what I really like about reality capture, that you have to have redundancy, right? Because the more accurate equipment will take longer to be accurate. So it will take longer to set up. So it's a really good question to do I need this type of accuracy for what I'm going to do, right? And that's what we want you to take. So there's a lot of different technologies. You'll see SLAM, LiDAR, which we'll be talking way ahead. We're talking a little bit on satellites with GNSS, so RTK, PPK, AR with GNSS. So those topics we'll be covering here in this webinar. So we hope you learn a little bit more.
Absolutely. And I was just going to mention, like, yeah, emphasize what is your end deliverable? What are you trying to achieve as an end result? Is it as-built documentation that you want to submit to the owner? And that is very valuable. If it's a
Yeah.
long-term facility, maybe they do need that information. It needs to be very accurate. But if you just really want to share information between the office and the field, maybe photogrammetry is really good. And you'll see the 360 integrations from companies like QPix that are out there. They're doing some amazing stuff with that, and that's a lower price entry point. But maybe that's all you really need. So,
Yeah, totally.
all right. So now we're going to dive right in. We're going to get into the reality capture types. So there's a lot of types. But we'll kind of go through that pyramid of starting at photogrammetry and work our way up to the more advanced and trends that are happening right now in the industry, and then we'll get into the use cases with those types of reality capture. So we'll start with QPix. That's going to be, there's a lot of technologies that are doing this with the Ricoh Theta or the Insta360 cameras. You can see you can attach that to a pole. Very simple. You can walk out on site. Anybody can do that. Wear it on your hard hat, and that 360 camera is going to basically record and capture those. And it's also going to include panos. So you got not just photos and the 360 panos, but you can actually create the photogrammetry mesh from that, post-process that data, and then view that data in whatever software of your choice. Obviously, we can bring that right into Revizto. But really, the beauty is how easy it is. And the fact that you can capture this just by walking around for 10 minutes and then process it. You have a record now of every kind of milestone captured. It's lightweight, it's very inexpensive. So it's really good at documenting those large areas. It's not going to have obviously that pinpoint accuracy, but again, it's not what you really need for what you're trying to provide. So we're just trying to provide information and really fill that gap between what the field's seeing, and then transform or translate that back into the office so they can view it, because we can't always be on site at that
Yeah.
time.
Yeah, what I really like about like QPix is that really offers a good solution for high-paced projects, because sometimes you don't have a lot of time just to like survey data. That way, if you're just walking around with just your 360 camera, that will give you a lot of information, right? And that I feel like that's really useful.
Yeah, so what you're seeing here in this video is kind of like the integration that QPix has developed.
Wow.
The first people actually that have developed this true integration, where you can bidirectionally create issues between either platform and sync them back and forth. So imagine being out in the field and you see obviously a discrepancy or something that the VDC team didn't see. Being able to communicate from the field that data and send it right back to the office. And obviously in Revizto, that's a great coordination software where everyone can see the models and the drawings. And then now they can see the field issues and really instantly, right? And then now they can comment back, send it back to the field, because the field's going to be on site, documenting all this information. So there's just a great bridge now with that integration to basically batch pano. I don't know if you guys saw that, but you could basically batch pano the 360 panos of the issues right back into Revizto. And that way the VDC team is up to speed with what's currently going on. So the collaboration is really strengthened here between the office and the field. So very
Oh yeah.
excited.
Awesome.
Right, so moving on to photogrammetry. I mean, this has been around for a long time, so it's nothing really new, but it has gotten better at the accuracy and then the quality and the amount of data that can be captured. So you got companies like Drone Deploy and then DPRs using a lot of their software on the processing side.
Yeah.
To really capture these massive sites. It's really a powerful tool for large site areas. And for site logistics planning and excavation and earthwork. So you're going to kind of see some of those use cases, but I guess the main things that I really want to emphasize is how relatively inexpensive it is. I mean, anybody can really, you can use your cameras, a phone, you got your Matterports, but the drones are really how you're going to document those hard to reach areas and large areas that you can't obviously walk and capture with just a normal phone. So yeah, this is
Yeah.
really, yeah, go ahead.
Yeah. What I would really want to add is that with photogrammetry, it's like it's a really friendly process. All you need to do is to take pictures. In the case of drone, you will need to rely on a flight pattern. But nowadays, like technologies like drone deploy, they offer that based on the extent of the area that you want to survey. Will take that point cloud and it will offer like a suggestion of flight pattern. So everything is pretty much solved today. That's pretty cool. It's a really nice time to live our lives now and work in this. So
Yeah,
yeah.
everything's becoming kind of autonomous, you could say. I mean, now they even have technology where the drone comes out of like a
Oh
shell,
yeah.
like it
I've,
basically blooms out of a flower. You don't even need to be there. You could set that, kind of like an alarm. It goes off, it opens up, it takes off, it flies its pattern, and it comes back and recharges. So, I mean, there's just too much
yeah.
technology to talk about, but those are the things that obviously are huge benefits. You can't always be on site. Um, but yeah, the algorithms and the AIs are doing some serious advancements with this technology. And
Yeah.
I just want to emphasize the quality. I mean, you could see, DPR is using this to verify, that their trench work is correctly located, and you could see that being overlaid in Revizto with the actual model, and it's just a visual inspection.
Yeah.
And then obviously you can record that once it's been buried, or once all that pipe work is installed, you can obviously
Yeah.
capture that. So
And hence this is all earthwork. Something that it I really like is that it's so quick because flight the drone would take you like 10 minutes. Process that data will be like another 10 minutes. Upload that to Revizto and you can go with that information fresh out of the oven and to start like telling what or the operator of the how you call those like I forgot the name, but yeah, you can concile information in real time, let's say like that, on the field, on the site. So that's like a few of the like workflows that I used to do back in the day.
And this is again a lighter weight, so we're going to get into scans, laser scans, but this is photogrammetry is very lightweight. It's an OBJ mesh or FBX, so we can import either of those formats, and
Yeah.
they are high quality textures that come with those meshes. But yeah, super lightweight, so it's easy to do. It's a low price point of entry, and yeah, it works really well with a lot of software. So again, showing that level of detail, you can kind of see that there. But this is just a fast way to capture large areas. All right, so moving on, we're going to go ahead and kind of talk about some LiDAR scanning. So this is going to be JTM Construction, which huge shout out to JTM. They're a huge partner with Revizto, and we just really like what they're doing. James and Morgan and Knight Davidson over there, just huge help putting a lot of this together. But yeah, they really do a great job with their surveying team and then with their VDC teams out there to capture really any of the existing spaces, any retrofit work. And they also use it for obviously a lot of pursuit work because it's very fast to be able to consolidate all that information,
Oh
show it
yeah.
in Visto. So why do they do that? I mean, obviously risk. Again, we're trying to mitigate risk as a GC. They carry a lot of risk. So we want to make sure what we're installing is absolutely correct. And we also want to verify what's existing, meets the intent of what's designed. Because remember, the design team is going to design based on a lot of things, and there are assumptions that have to be made. They might not have access to, obviously, the scans. So they got to go off of older drawings. And with that, obviously, comes that margin of error. So what you're seeing here is the design model being compared against the reality that was captured of this existing hotel in Seattle. And you can clearly see where those design variances are. So very easy to do that, mark it up, send it back to your designers, and then just confirm that, yeah, that beam is in the wrong spot. We'll update the model and then move on.
Yeah, sure.
Here's another example GTM did to really prefabrication. So prefabrication is obviously taken off too with the advancements of VDC. But it's the information of the as-built reality that we want to really emphasize here of how that helped them, with a subcontract that's responsible for this work. I believe this was like a underground storm drain or some sort of filter system that they were trying to install, and they needed to create a custom lid to match the existing site conditions. So with Revizto and obviously the LiDAR scanning that they used here, they're able to get that, with very high precision, 3 to 4 millimeters precision, verify the existing elevations and the dimensions that were required to meet that existing lid or manhole drain. And then you can kind of see that shop takes that back to their shop, works in a nice, pristine environment. I mean, this is super ideal, obviously, to be able to do all this without having to go out there with a tape measure, go back and forth to make sure it's correct. You have that assurance now up to millimeter
Yeah.
precision. So it can fit like a glove when you install it on site. Okay, so some of the other things that we can do in Revizto is obviously our clash automation, which is superior when it comes to clash automation with all the bells and whistles that comes with, and then automatically assigning the clashes to the correct trades. You can see we can also do that to point clouds. So this is a scan of an existing mechanical broom. You can see we can, take the design model. Obviously, it's got to be kind of geo-referenced to make sure it's in the right spot, which we'll cover how to do that. But once you have all that, now you can run a clash test on it, and it'll automatically figure out where the clashes are with the point cloud, highlight them, and then you can see with our advanced automation, we can assign that to the right trade very simply. So very cool to be able to do that. And then I think one of this is probably the most favorited feature by the field is the ability to see all this information on your phone or on your iPad. That's never been done before. I wish I had this, 10 years ago.
Oh,
But
yeah.
yeah, this is a dream, for the field because they're used to drawings. So they're not
Yeah.
going to go away from the contract, right? They have to build off of the drawings. So you're going to see that two-dimensional drawings are what they're going to use. But to have that context, now it enriches the data, which is, everybody wants the data to be, consolidated. It's all over the place. So being able to integrate all the 2D, the 3D, the reality capture, and then document all the issues all in one platform, that's really where Revizto shines.
Totally agree. And like in the past, I was like a real good user of Revista. Like having this kind of context on my day to day, it was like a great tool to use on the field, and that really helped out totally. And to have like reality capture with your model, with your intention of design, and cons con coordinate that data with 2D sheets, it's like wow, was mind blowing. Yeah.
Yeah, and so we're also seeing that geolocation kind of come into play
Oh
here
yeah,
because
totally.
again, this was imported and it puts it exactly where it needs to go. So you know that the reality, that's reality. It's geo-referenced, it's
Yeah.
accurate. We can trust that. So now we can back check against the model. Did the model obviously miss something that we didn't see in the field? Or is there a conflict or a discrepancy between
Yeah.
what was installed versus what was planned? We can highlight that and then make sure the field actually fixes it to match what was planned. So you're going to start to see these use cases kind of sprinkled throughout this presentation, but DPR, again, doing an excellent job out there in the field. Mike Jakes over there in Sacramento, huge shout out to him. But he's using terrestrial scans, obviously, and LiDAR scans to back check the work. This is just an example of how you can take the captured reality of what's going in on the rough end for drywall and framing, and then bring
Yeah,
that, overlay that with your model, color code it with an appearance template, and then obviously use that 2D overlay feature to really see all that rich context all in one view. Send that to your field, and then make sure you call out, where there is a bust, they can easily fix it, and then the problem solves. So
yeah. And I am no Italian, but all I can say is bravo. It looks amazing. Yeah.
it's amazing. And you can save these views. I mean, that's what's beautiful about, I guess, Revizto again, is
Yeah.
we don't expect the field to know all these bells and whistles, all the tools. There's a lot of tools. So the VDC manager really gets to do what they want. They could bring it all together, make it easy button for the field to click on, and that save that view. And now they click on it, they see it on their phone, and they're like, oh, yeah, this is
Yeah,
exactly the area I need to
exactly.
work at.
It's the easy use and the ease of access. What I really like about Revista and the ease of like the optimized navigation that you get. And for general meetings, this is perfect.
Okay, so now we're gonna move on to kind of how they set up controls. So there's gonna be various ways to set up control, but the most common uh, is gonna be GCPs, using target GCPs, which are ground control points that are set usually with a total station. You're gonna have a total station, and that's gonna be kind of like a surveyor is gonna use that to, know exactly where that control point is in space, and it's going to have an XYZ coordinate based on your state plane, or it could be local, which we'll talk about either one, because some people like local coordinates, some people like the state plane projected coordinates, but JTM is definitely using that to kind of, align their reality capture with the actual geometry of the design. So you can see here in Revista, we can see the 2D, the 3D models color coded with the LiDAR scan. This is using SLAM technology. This is a Navis VLX, and you can see very easy, very mobile. It's very fast. It's probably 10 times approximately faster than setting up a fixed terrestrial tripod scanner, which have a more, those are going to have the highest level of precision when we looked at that pyramid structure. But the SLAM technology is advanced quite a bit with the algorithms that are built into it. It can really create very accurate, minimize drift, and you're getting about 4 to 10 millimeter precision based on what type of hardware and system you're using. And then obviously there are best practices to increase that. But yeah, it's the turnaround time that really make this a really useful tool. So
Yeah, totally. And Matt, something I really like about Navis is that they love to design with ergonomic. So, for example, that little screen that you have right in front of your face will like
right,
in real time let you know which places you have scanned and which ones you have not. So you can avoid, like getting shadows or blind spots. So that will provide you for more information that you are doing in real time and really good quality scan. And you don't want to go back in the field just to like add a little bit more information. So definitely that will improve your efficiency.
yeah, you're absolutely right. This is kind of in real time as you walk, you'll see this
Yeah.
blue density kind of increase, but it's really based on your walk pattern and coverage that you're getting. And it's kind of showing you where, maybe you need a little bit more coverage right there. You can see a little black area right there. So you're going to walk back. But this is basically recording and registering your scan in real time as you're walking. So that's the beauty of SLAM technology, is it's auto registering as you go. And it's basically showing you a coverage map, which
Oh
will show
yeah.
you kind of what that looks like in another slide. And just real quick, there is a case study which Stephanie just posted in the chat. So if you guys are interested in learning more about how JTM utilizes Revizto and their, the reality capture best practices that they incorporate, please click on that link. That'll take you directly to that case study to learn more.
Yeah. And Matt, and if you're getting problems, hitting your 10,000 steps a day, try becoming a surveyor. That's my great advice. It will get you.
Yes, here's another one, kind of giving you an example. This is a high rise that they built in Seattle or Bellevue. But you can see again, amazing to be able to take that captured reality on site and then compare that visually against your model, quickly verify if there's are discrepancies, which you can see there's very clearly there are none. I mean, structure is very precise, it has to be, but it's just a great back check. And, and obviously you can continue to add more and more scans as you need or unload them with our model unload and unload presets, so you don't need to bog down the resources on your computer. But those are just some of the things that JTM's been using. Appearance templates, as you can see, with a click of a button. Amazing. You could just turn on the MEPs, and now you can verify the MEPs color coded against the as-built conditions.
Well, amazing. Yeah.
Dimensioning. There's just a lot of tools in here, so really useful, and it's going to be very accurate information there. Okay, another one. This was the same Navis VLX that was used. This was at Oracle Innovation Labs when we were there with Drone Deploy, and yeah, they scanned this, and it was amazing. Like they scanned that probably in 15, 20 minutes, and you can see again back and forth. I'm just showing you how stunning the reality capture is, and aligning it, georeferencing it with the models. You turn that on with your appearance template, and there you can see where the discrepancies are. And obviously, this is fine. That's pretty normal. We're
Yeah.
not going to model the trusses exactly the way they fabricated them, but it's these things. Like we can visually see that storm drain is, installed in a very different location, and there's probably good reasons.
Totally. Yeah.
All right, and then last but not least, you got your fixed terrestrial scanners, which have the highest level of precision. They are going to be geolocated, most commonly using a total station control. It does take longer to set up and process, and you're obviously going to need registration software like a register cyclone and recap. But you can see this is that's the deliverable you're looking for, because this is high risk. So you want that very accurate information. Bring it into Revizto, document the discrepancies, and then send them back to the field to fix. So again, JTM does amazing work out there using both methods, like products, Navis for the SLAM technology. So,
Yeah.
okay, and then this
Totally.
is another one. This is new, kind of new. Gaussian spotting's been around, but it's kind of like the fusion that I'm seeing now. So X Grids, I met them at RCN, amazing company. Just kind of came out with these new products, which are advancing rapidly. But look how compact that is. You can hold
Wow.
that,
Yeah.
walk around again, 15 minutes, I bet, to take this, get this, and it's going to create that point cloud using SLAM, which is the simultaneous localization and mapping. And it's basically able to stitch all that information, create the point cloud, and from that point cloud, they can create the Gaussian, which is basically a volume rendering technique. Rather than using a solid surface, it's using a Gaussian splat. So it kind of creates that fuzziness, but that helps fill in those gaps, which
Yeah.
is different than a typical photogrammetry. It's more rough and surface oriented. You can kind of
Yeah.
see the Gaussian here. It's fused with a laser scan, a LiDAR scan point cloud. And so it's filling in the gap, creating that more smoother transition. So it gives it that realistic feel.
Oh, yeah. Impressive technology.
Okay, and then like I think this is one of the last ones was the just the how compact everything's getting. So everyone's got these phones. But what we haven't seen is RTK, which Juan's going to go really into depth on that one. But imagine being able to scan with your LiDAR on your phone. So you would need a LiDAR scanner, or, your phones now, the advanced phones, iPhones are going to have that sensors on them with your camera, which have obviously improved drastically in the last 10 years. You're not going to get obviously the incredible accuracy or range, because your LiDAR on your phone is probably only good for 5 meters, maybe.
Yeah.
But with RTK, you can actually geolocate that in real time, which is
Yeah.
amazing.
What I really like is that this new technology really open up, like the whole reality capture in real time. So you don't, if you have like a really busy surveying team that you rely on, and you want to like anticipate like their task, and you want to absorb a little bit, these are ways that you could survey pretty simple information and have that information you reference. So you just need to like upload into Revizto, and you can have that as a really good as build asset in the future. So that's really good.
All right, so last but not least, definitely wanted to highlight the new AR. So there's a lot of AR for sure out there, but we wanted to make sure you guys were aware of augmented reality and being able to take the model and overlay that with your phone based on the real world. And you could see that's basically now located and positioned to match the exact location in the field. But yeah, just superimposing your model using your phone over reality is really what augmented reality using our Revizto site app allows you to do, which is super powerful for anybody just quickly trying to, see where there are any discrepancies or for facility managers that might want to, kind of compare the existing or the existing conditions against the actual planned
Yeah.
design. So,
Yeah, and something that it's really useful for is that if you are capturing like point clouds and stuff like that, that it's underneath or it's not visible, you can use
hmm,
AR just to see those elements. So for
point.
facility management and operations, like if you need to do a renovation and you want to, I don't know, incorporate a different structure and you need to see what's in this wall, if are there any systems buried inside like underground or something like that, that will really help. And Revist is like the few up like AR options where you can see that type of information, like point clouds and OBJs within
Yeah.
AR.
It's a good. I'm really glad you mentioned that because that is one thing that most people forget is like what happens when that scan is or when that deck is poured.
Yeah.
How are you going to be able to visually see it? So with augmented reality, as you can see, you can now see that point cloud virtually, overlay that with your phone, and now you can pretty much see through really whatever you want. The walls, you can see what's behind the wall and compare
Oh
that
yeah.
against the reality. So that's super helpful to be able to have that. And it's going to be available to anyone because pretty much everyone
Yeah.
has a phone, right? So
Yeah. You
that's
don't you
really,
don't want you don't want to drill a LPG pipe, right? Or a water pipe, a water pipe. That's not good.
all right.
So now let's talk about your reference and coordinate system. So this is really complex, and I'll try to narrow down the like just to explain the main concept. So basically, what you need to know is that we live in an ellipsoid, so it's not a total like a perfect sphere. But what you need to know is that the curvature of the Earth might change depending on where you are on the planet. But as you know, our projects are not as extend for you to consider Earth's curvature. So what we do is that we use a projected system. So let me just draw a little bit here. As you can see here in the planet, we use what we call the WGS 84 coordinate system, which relies on degrees, minutes, and seconds. So you will see these lines, which are latitude and longitude, and they generate these squares. As you get closer to the equator, these squares will be closer to a square shape. So there will be less distortion on your plane. So that's one thing that you need to know. And when you are getting close to the poles, like the shape will be like this type of triangle. So the distortion will be most visible. As you can see here, we have the exact example of Antarctica. So in this case, you will see when you see it on a map, it looks huge, but in real life, it's not that big. So uh, that's that's something that you get from doing those transformations. But remember, our projects are not that stand, right? Because you don't need to consider like this these changes of curve, like when these type of cases that you see here, because it's so extend that you will see things like that. So basically, when you do a transformation or a projected, when you use a projected coordinate system, every line that you draw or lay out on the field will be a straight line. So you shouldn't worry about like that type of distortion and stuff like that. And that helps to really represent the 2D or the 3D data in a 2D world. So that's why we use projected coordinates. And those are projected. Also, one way is to like UTM. Basically, what it means is that it's UTM means Traverse Mercator. Yeah, so what you are doing, it's like you're putting a cylinder around the earth, and you are projecting like each place of the earth on that, like on that paper. Imagine you have a globe, and you are wrapping it with a paper, and then you extend the paper, and you get this, right? So basically that's what you need to know. And how everything it's set up, it's by using EPSG codes. So you could use UTM codes, but we prefer to use EPSG. They are like more standardized, and that's like where the trend is going on coordinates. And if you want to learn more on that, you could check this transformer. It's the EPSG official site, and that way you will be able to see which kind of coordinates are available in your region. And also, I would recommend for you to check your local regulation, because usually that's standardized by law, right? Because, for example, municipality or counties, they need to use the same coordinate system in order to like or do some urban planning, do like service or their of their line water lines and stuff like that in those systems. So that's why it's so important to work in that coordinate system, right? I hope that really pretty much covers. And now, how can you use those coordinates? Basically, we have three main methods. So we'll be with total stations, which it's an optic method, or it's equipment that relies on optics. So what you do is that you will start with monuments. And where are those monuments placed at? For example, something that I really admire about the US is that you guys have that everything like really well organized, your public information. And in this case, you will see the NOAA website, and they have this information. So you will be able to see where are your where the main monuments for reference your project. So that's something that you could do. You could start with that, with this placing your total station here, and you can move and transform that point over there, and you can georeference your project. And if you click on each monument, you'll see metadata of that monument. You'll see pictures around it. You'll see the coordinates of each one. So that's pretty cool to know. After that, you will see the GNSS triangulation or GPS. It depends on what kind of systems of satellites you are connecting to, but basically it works by triangulating your position with satellites. So you'll have this, you'll see this in 2D, but basically it's in 3D. So there are like satellites flying all around the orbiting the Earth. So you'll connect and triangulate that position. The more satellites that you get, the error will be way or you it will be more accurate. So that's what you need to know. And local coordinates. If you don't want to work with all of this, you can work with local coordinates. But we do ask you to have like start working with a arbitrary quadrant. You know, if you want to start in 100, 100, that's something that you could do X, Y, Z. But you need to have a logic on the placement of your project in order to use that system. In the end, that's going to become a system, even though it's relative. Next slide, bro. Now, pros and cons of each type of method is that total stations are really accurate. You know, they rely on optics, and optics are like, pretty accurate on measuring light. It's suitable for environments, what meaning that if you go underground, it's going to work. Actually, in mines, they need to rely on total stations. You can work with local coordinates. It's easy to document points, and obviously you look like a total boss using it. I'm not gonna lie. The cons are that it takes a lot of time to set up, and it's bulky to carry. Usually it's operated by teams, so you will need the operator of the total station and an assistant using a target. It requires a lot of previous work, as we mentioned, because you need to use control points and you need a clear line of sight. So there's nothing worse than having like some sort of obstruction in your line of sight. So you don't the you don't want to move your total station after setting up. So GNSS antennas, they're pretty quick to set up. You can easily, as well with as the total station, you can work with local coordinates. You can document points, and it can be operated by just one person. So that's good, right? Cons, they have they are less accurate than the total station. And obviously, it depends on how you are using it. We will explain that later on. And weather might affect the accuracy, right? Because you're connecting to satellites. And local coordinates, that's what it's really good for, is that it mitigates the survey food and international food conversion problem. And that's something we in metric we don't have, right? Because you guys have in Imperial that type of problem, but using local coordinates might will solve that. It's more use software friendly for things like SketchUp, and the cons would be like you would need some type of geo-reference post process in order to reference that information to work with future projects or stuff like that. And it's not uh, interoperable with different technologies. For example, like photos that they record a position, a GPS position. If you want to like know where that photo was taken in your project, you won't be able to. Next, this is how like this is a really good diagram that Matt did on how RTK technology means. RTK means real-time kinematic. So what we are talking about is that you are always connecting to a base. You are always have connections to that. So what you need to know is that you have your satellites, right? And you're going to use a base. And this base, basically, you have two options. You could have your own, or you could connect to a public domain one. In this case, it's called Ntrip, the network of bases that you have available. It's one payment only, and that will be like set up inside your collector or your rover antenna. I'll explain that later. But what you need to know is that you have those two options. Obviously, if you work with your own base station, you'll be more accurate on your position because it's closer to your rover. And what you need to know is that your rover is the equipment that you are moving with. So it could be an antenna, it could be a drone, it could be like uh, whatever, whatever equipment that has an RTK module, and that's key, right? And what it does is that it is connecting, even though you're moving, it is connecting to the base station, and it's auto correcting the position or or
Mm.
the readings that the rover is receiving. And if you don't have like a connection with a base antenna, you could work standalone with just a rover, but you're going to kill the accuracy. Something good to note is that even though you're working standalone with just a rover, will be more accurate than working with just a GPS, like in your cell phone and stuff like that. So just to give an example, GPS will work around like 3 meters accuracy. If you work alone with just a rover receiver connected to a satellite, it will be like 30, 40 centimeters. So I mean, it's way better.
Right. And it's just so you know, I mean, I think the end trip, last time I remember looking at the specs, it's about, I think, I want to say 30 millimeters in accuracy, so about three
Mm,
centimeters. I think if you actually have a stationary, which is a lot closer and the signal's good, it's auto-correcting your position in real time. That's can be up to 3 millimeters, I believe. It's very accurate. So obviously that's something to keep in mind.
yeah, totally. And now, what if I want to keep it local? I like to like reveal a little bit, and I'm gonna use my own coordinate system. So what we recommend is that always place a grid system in your site plan. That way it will be so easy to align grids and just take the site plan with your reference data, import that like DWG file into your architecture Revit model, align the grids, and you will see your monuments, and you will read the new coordinates of those monuments. So that way you can override that information in your total station or your in any RTK workflow, because RTK workflows, they can work with GCPs as well, even though they are connecting to satellites. So that's where this knowing this will really help you out on using this high precision equipment, even though you are using local coordinates. Something that you need to know about point clouds and the reality capture formats that you can bring inside Revista, because there are a lot of file formats out there. For example, for point clouds, you will have ALS, which is pretty common to use. Uh, those point clouds will be your reference, so you can do direct imports in Revista, and they will land where it should be. Uh, Recap, which will be RCP, RCS, and Faro type of um, outputs. Texture models like OBJ and FBX will get you more detail using photogrammetry that will help too. And orthophotos or orthomosaic images, they usually use GIFs. Right now, Revista is not compatible, but one workaround that I really like, because I have clients that they only work with 2D data sets, is that you want to bring like your ortho images by importing JPEGs in Revit or something like that, and or you could your reference inside AutoCAD, Civil 3D in this case, and you can import that sheet into Revizto, and you can do an overlay inside Revizto. So that's really useful. And also you get a lot of information of your surroundings and property lines and all that sort of stuff that it's pretty useful to coordinate in your project. Yeah, um, this is useful to know, is that when you're working with terrestrial scans, you can have like different outputs, like structure on structure scans, right? We're talking about like structure, and what it means is that you will save all the information of the different scenes that you are recording, right? Because you are moving manually your scan, so it will record that scene, like that information that it surveyed. And that way you'll be able to access to the panels. So in the next slide, you will see that example. You can see here in the structure scan, you will see that in that case, you have two locations, and you will see where are those placed, where those were placed at, and you will see spheres where you can get inside the panoramic image that it generates. And something good to know is that those are really useful for real estate, for live tours and stuff like that. For a structure scan, what you need to know is that it takes the whole scan as a one piece. So you won't get to see the spheres, and you won't get to determine like the position of each scene or scan. And what cons you have with structure scan is that you have that information, but if you go on structure, it's easier on the file size is way smaller. And with navigation inside, like inside Revizto, what we take is on structure or unified type of scans, and that will improve the navigation and the consumption of that information when you are doing coordination. A little bit of registration. If you go back, Matt, just on the another one. If you go back, and registration, that really helps when you have errors on just one scene, or you just did like a local scan, and you want to register or align that scan into your environment or your coordinate system. So that's a really good way to geo-reference that as well. So that's a key concept that Slam really takes on, and you will see later on. Matt, this is all you.
All right. Yeah, so we're going to definitely talk about how to collect basically photogrammetry using RTK. So this is definitely kind of like the tool set that you're going to use. This is actually what Juan used. He actually has this set right here, the DJI Air S2, and we are going to basically geolocate this flight, or basically the controls, in order for the photogrammetry to morph itself and position itself correctly. Because without that, there's no way the photogrammetry knows where it's located. It can create a nice mesh, but what we want is we want to create something that tells where that model actually lives in space. So this is
Yeah,
the receiver that Juan was using.
yeah,
This would be the rover, and then this is the data collector.
yeah. Basically, what we just did, we just took we just did a drone flight around a property, and we used RTK using N-trip type of base connection in order to record the GCPs. So basically, on this process, real quick, will be check your parameters. There are ellipsoid type of parameters that you need to be aware of because the drone uses WGS84, and we want to get those GCP coordinates in that type of coordinate. And just check your satellite connection. That's pretty useful to do. As you can see, there's a lot of, GPS, GLONASS, Galileo type of satellite systems. And also, you would need to check or wait in for your base to triangulate. In this case, as you can see here, you will see that we started like real big error margin, and we narrowed it down up to 2 centimeters, which was useful for this case. Go over to the next one. Now you would check where you are placed inside your because each collector has like a Google Maps interface, so that's pretty easy to know where you place that, and all the parameters are where input correctly. And something that it's really useful is that you can see in real time your error of reading, and if you are fixed, right? If you are having like any type of connection problem, that will be noticeable here. And also, we recommend that when you start surveying, use codes. That's really useful for filtering out like all that information that you are surveying day to day. That way, it's easy to make reports. So yeah, that's how we use the code for GCP. So that's good to know.
All right, so what do you do when you get that data collected? That's going to be your controls, right? So Juan, what he did with that rover with GNSS, he was able to collect and position those control points. You can see in this, well, it's hard to see, but there actually are, I believe, 3 control points that he staked out on site in various locations. And this was in Costa Rica. It used I think there's just one state point coordinate system that they use, EPSG code. Is that right, Juan?
Yeah, we are so small that we only have one one coordinate system. Pura
Yeah.
vida.
Pura vida. So yeah, you can see here's the photos he took about 188, I believe. So photogrammetry software, there's a number of them out there where I used Reality Capture by Epic Games. They do an awesome job. And we translate those. So we translate it from WGS84 geodetic to state plane coordinate system. That's the actual region that Juan lives in. And
Yep.
then you can reconstruct it. But before you do that, you want to basically tell it what those targets are, and you want to take that control point. So what we did, we import the CSV file from his data collector, which has all those coordinates, the longitude, latitude, and altitude. We basically map that to those controls through the CSV import, and then we can now tell the software where those targets are located. And what it's doing is it's going to basically say that uh, GCP is now that it's going to be mapped to that control. As a result, once you reconstruct the photogrammetry, you will reconstruct it, which is going to stitch all the photos together. It can now geolocate that in space and tell you where that model is. It's not going to be, again, the most accurate because it is photogrammetry, but this is kind of what a result would look like when you bring it into Revizto. You can see it's very easy. And this is a point cloud, and it also includes the OBJ mesh, so textured mesh, separate from the laser scan, or not laser scan, but the point cloud. You can kind of see what that quality looks like. So super easy to do.
Yeah. Now, what if you're using LiDAR with RTK type of workflow for reality capture? In this case, we're showing like a use case where a Matrix 300, which is a DJI drone that has built-in RTK antenna. That way you can connect to a base, or you could connect either entry. I mean, those are like the two options. I would recommend to have your own antenna. And with the SEMUS L2, which is just one LiDAR sensor, um, now we can show the results because that's a really good equipment. It's more costly, right? But it's going to deliver more information, and it's going to be easier to post process.
Yeah, that's the
Um,
LiDAR on the drone, just so people kind of know what we're talking about. That's the LiDAR sensor. These are your antennas, I believe. I'm not sure which one it is, but that's probably your rover antenna, right? One.
Yep. Yeah.
All right. So this is, yeah, one. If you want to talk about this, this is
Oh yeah.
the
In this case, we're showing like all the survey data that the drone captured. It was your reference, so all we needed to do is like to uh drop that in inside Revizto, and it was pretty easy. And something that I really liked about this project is that we had like, as you can see there were like those red trees, which means the trees that were meant to be cut down. So that way we could verify what type of implications you have with those trees, even when you are doing earthwork and stuff like that, and even help out on our planification of the project. So as you can see, reality capture brings a lot of options and a lot of new workflows and how you can consume that information in order to plan better in your project. And also we have that one. It was an example by using just photogrammetry. So you can combine like everything, like different type of reality captures inside your project, which something that I really like to do.
So I'll cover this one. This is SLAM. So what we were looking at was SLAM technology um, on a drone. But this is also, there's other ones obviously that are you can do just on the ground. So this is more terrestrial, ground-based workflows. Same concept where the RTK module is integrated into the SLAM technology, a mobile solution, a handheld device. And what you're seeing is the mobility and the ease of access. But what's cool about this is not only are you getting that high density point cloud using LiDAR sensors, which is shooting millions of points. We'll see in a second. You'll see how that works. It's really cool. But it's
Yeah.
actually able to, geolocate and position the scan in real time. So RTK, real time kinematics, is allowing that scan to register or auto registering it, and it's geolocating it in real time. So very fascinating and very efficient workflow for sure. And the range, that's something I wanted to mention with this. You can see the range is very high. I mean, you can get lower cost options that have lower range, but this one's able to scan 120 meters and get very high density with very good absolute accuracy. You can see there. Okay. And then this is a more traditional method. This is SLAM technology using the Navis VLX. That is going to use control points or GCPs. And those are going to be laid out first by a surveyor using a total station. But what's really nice about Navis is you can basically you can go over those control points. So every single dot you see here on this map is a known control point where they actually staked out, because what they're going to want to do is geolocate this scan. Because right now when they scanned it, it's all local coordinates. So the scan isn't geo-referenced, and maybe that's fine. You don't need it geo-referenced, but maybe you do. If you want to actually bring in that scan and match your model that is geo-referenced, you're going to need to use, those control points and map those coordinates to geolocate. So just so you kind of know what this workflow might look like, here you can kind of see what that SLAM technology did when they scanned that street. They scanned quite a bit of area in about 45 minutes. You can kind of
Wow.
see, yeah, what that path looked like when they started. Minute one started. You can see they did quite a few loops. So probably an hour worth of time out there, but it's providing that high density scan. And you can see the X marks the spot is those control points. And basically you bring in the civil survey control point file, which is going to be a CSV or a TXT file. And you're going to open the scan in the post-processing software. And when you're ready to map the coordinates from what's currently local, because these are all just local coordinates when you start the scan. Well, when you're ready to export that data, you're going to want to remap that, and you're going to do that by importing those survey control points from the total station, and it's going to remap that. Every single control that you see will be remapped to the state plane coordinate system that you choose, which is very amazing. But
Yeah.
that's very common on these scanners that aren't using RTK. So this is what that would look like right here. You can see in the processing task, you would import that, and there you go.
Oh
All
yeah,
right.
and this is like a really breakdown on how a LiDAR scanner work. using SLAM technology. So basically, what you need is a lidar sensor, will be a depth sensor, and also gyroscope and a 360 camera, just to colorize those points, and also a processing unit, which is going to be a backpack with a mini PC. So as you can see, this is a really good DIY lidar scanner that you could do. If you go over the next one, you will see it in real time because the lidar sensor is going to use those type of patterns. I believe this is like a globe type of a pattern. So what it's going to do is to locate each point that where the laser will bounce off that element that it's hitting. So that way, with the true depth sensor, is going to facilitate, the registration, and with the 360 cameras, you can see it's when it's moving like closer to certain elements, it's going to colorize that. And that's happening in real time. That's something I really like about this, that technology is getting way better, more powerful. So, but how can we improve with software? Because SLAM relies on software. And if you go over the next one, Matt, you will see what is the implication on auto registration of the software. So that way we have like different optometrical type of softwares and different algorithms. And as you can see, if you go further to the right, you'll see that the auto registration will become better because with SLAM, something that you need to be aware of is that you can get drift, right? And as you can see here in the first in the first example, you will see a lot of like drift here. So that's something that you don't want, especially if you're doing this. And since you don't have the ability to do manual registration with those type of scans, that's where like the software and the algorithms they need to do better, be better, and that's why we recommend like going and starting with companies where you can try out their technologies and stuff like that, because you know they trust their algorithms, and they will get better on time, so the drift will be minimal, and you can have more accuracy in those processes.
All right, so yeah, last but not least, we'll just finish out and close out with the best practices. So yeah, Juan, if you can take the total station, and I'll
Oh yeah, basically what I just want to stand out is that you have really good accuracy. It's suitable for most environment, like because GNSS antenna they don't provide with that, and also the time of install of setting. So that's something that you might need to be aware of. So that's really good practices to know which kind of workflow these type of equipments are better for. And if you need to use local coordinates, try to use what we just told you about, like inserting grids in your site plans in order to go back and forth between geo-reference and local. That's good. And terrestrial scanners, I would say like have your control points laid out before scanning. Try to build a perimeter because you don't want people going near your equipment while scanning. You don't want vibrations. Be aware of high reflections elements such as glazing and some sort of they're like steel paints or metal paints that might cause that problem. Plan ahead your locations in order to get the most coverage of scanning in the least amount of scans. Try to use higher elevations in order to get more information with just one scan. And if possible, try to upload a DWG file into your collector in order to see that everything is aligned. For SLAM, I mean, use control points to increase accuracy and geo-reference that scan. Use closed loops to ensure that you get really good coverage. Try to work smooth. That's something that they have compensators, the motors and the equipment has that. But if you can help out the equipment, that will be good. Try to move slower in order to get more detailed information. As you can see, that's an iteration of information that it's collecting. Try to classify point clouds. We didn't talk about that much, but you can classify point clouds, for example, Trimble Business Center does that. You can classify vegetation, terrain, buildings, even outdoor power. So that way you can upload different information in each scan, and that way will reduce the amount of the size of your scans. Yeah, and if you can try to reduce the density when you are uploading in Revizto, so that way you have like better navigation.
Yeah, and it's just for drones. I mean, the main things that we keep in mind is really just the precision. It really depends on a lot because the photogrammetry, like I mentioned before, is not going to have that high level precision, regardless of how good the camera is. But it will be affected definitely on the quality of your camera, the number of photos that you're taking, and then really the GCPs is the biggest one. So the more GCPs, it will take more effort, but you will get a tighter knit of a mesh and a tighter accuracy on the location of your data. And then the
Yeah.
GPS exit data, I mean, that is embedded in every photo you take. So that also takes into account the reconstruction of that photogrammetry. It is looking at that GPS data. Uh, but yeah, and other things to consider is going to be the flight altitude. So the higher you are, obviously you can cover way more ground with fewer photos. But again, that has to compromise with the quality of your photo too. Uh, Battery life, and and then last but not least is the flight pattern. So definitely, like Juan said, you can use autonomous methods with AI to program that drone to fly, and basically it'll optimize that flight based on its battery life and get exactly what
Yeah.
it needs. But a more manual approach, which is very traditional, I mean, most people are going to fly just a typical grid over the top and really capture those views. And the spacing really just depends on how large of an area you're trying to cover. But we would recommend definitely a top view grid and then go around it again at a lower elevation at 45-degree angle views, and then obviously go around the entire site with a 45-degree view. That should give you enough coverage to create a nice photogrammetry 3D mesh. All right, so sorry I went a little long. We have one poll question, and thanks for those that stayed on for this entire webinar. So we just have one more question, if you guys can fill that out. We just kind of want to gauge the audience and see if you guys would like this webinar, if you're interested in Revizto and want to hear more, or if you're already a customer, just let us kind of know, and we really would value your feedback.
Yeah, if you want a part two, just make sure that hit like on our LinkedIn post about this webinar, so that way we will tell our bosses that it was a total success. But I don't see any today, so that's good. I take it.
Okay, so now we can move on to Q&A. We're just going to answer two questions since we already went over the hour. So thank you everyone who is still connected. So I have a question for you guys. What was the expert file type from Drone Deploy that was brought into Revizto? I assume it's probably one of a video of your slides, but I don't know.
Yeah,
That one was
yeah,
texturized. Yeah, so
oh
it
yeah,
probably was an
texturized
OBJ.
OBJ.
Yeah.
Yeah, because we're if you guys go on Drone Deploy's website, they'll probably have maybe some YouTube videos. I mean, you could definitely find out, but yeah, when I've used it, they give you a variety of different file types to download, and if one of them is going to be a point cloud file type, I think it's LAS, and you can also download the 3D mesh, because remember, a 3D mesh is photogrammetry, and the derivative from the photogrammetry is going to be that point cloud. So they provide multiple options.
Awesome. And then last question is, how soon will there be a direct export option from Navis Evian VLX3 or VLXM directly to Revizto?
Yeah, we hear this one quite a bit. In fact, I talk to them all the time when I see them at Reality Capture Network, and we're really looking. I mean, the dev teams are really trying to get that 3D API to allow that integration to happen. But I definitely see that's going to be everybody that's wants to get data or bring data into Revista is going to want to have that easy access to push from Ivy on directly into Revista. It's kind of like, but they would have to program that with the API. So I don't think it's going to be too long, maybe a year or two before that switch is allowed. But it would require API integrations to do that. So currently, the only way to get that right now is to download from Ivion that file site, LAS file, and then bring it into Revista through the file import.
Yeah.
All right, well, thank you so much, guys. We can go to the next slide. Obviously, if you guys have any other questions, please contact Matt and Juan Diego either through their email address or follow them on LinkedIn and you can ask them any questions you have. But I think Matt wants to say something else as well.
Yeah, I mean, if you guys want more, obviously please contact us because we can only get through so much in obviously an hour. We'd love to obviously do another one, so definitely let us know if you're interested. And then if you guys really want the best expertise, obviously, we have a, generalist understanding of reality capture, but we have Reality Capture Network, great partners that we go to their conferences every year. So check out their website, Reality Capture Network. Basically, they have a committee with experts, surveyors, and reality capture enthusiasts that are going to provide a lot of the same stuff that we talked about, but very specific and very detailed information as well. Case studies, best practices, all of that you can learn more at realitycapturenetwork.com. So, but I did want to say thank you everyone for attending and staying on longer. I know we went past the hour, so I do appreciate that. And yeah, we'll hopefully see you guys next time.
Thank you. Thank you, guys.
Thank you, everyone. Have a great day.
All
Bye-bye.
right. Bye.